Welcome back to another lesson. In today's lesson, we're going to learn about hyperbola. We're going to start with the basic hyperbola, that is y equal to a over x. From this hyperbola, we're going to understand what a means. That is, we're going to understand the shape of the hyperbola. And from there, we understand the asymptotes. I'm going to speak about what asymptotes are. And from the asymptotes, we're going to speak about the vertical asymptote. We also speak about the horizontal asymptote. And we also speak about the line or axis of symmetry. And from there, we're going to find the domain and the range. These four things are the most important things that you need to know about the hyperbola, and they're going to help you to be able to graph and answer questions about the hyperbola. So we're going to start with the basic hyperbola, and then we see how this influences the shape of the hyperbola. We're going to start with y equal to 1 over x. From this, you can already see that a is equal to 1, and it's positive. So we're going to draw this, and then from the graph, we're going to say what a means. That is, what is a telling us. As you can see that I have x is equal to minus 100 and minus 10 and 0.01 and 0.1. From here, I want you to show what happens when the number gets bigger and when the number gets smaller. So we're going to have 1 is equal to minus 100. And that is going to be equal to minus 0.01. Note here, when x is getting bigger, you can see that y is smaller. So you can see that y is an inverse of x. In this case, you can see that y is equal to 1 over x. So you can see that when the x value becomes bigger, y value is going to be smaller. And check again here. When the value of x is becoming smaller, that is getting close to 0, you can see that the y value is bigger. That's what I was talking about when I was talking about the inverse. And then when x is 0, you cannot divide by 0. So this is going to be undefined. So you do the same thing here. So let's draw this. When x was minus 100, we had minus 0.01. So we're here. And we saw that when it's coming close to 0, y is becoming bigger. And then when x was equal to 0, it was undefined. So we have undefined here. So we're not touching the y-axis. So we have something like that. So y is going to continue to be bigger, but it will never touch the y-axis because we said when x is 0, the graph is undefined. So even here, when x is becoming bigger, y is going to become smaller. For the positive side, the numbers are just going to be positive. It's going to be similar to what was going on the negative side, but the numbers are going to be positive. So we draw this on the positive side. So that's what we have. So from here, we can already see that, okay, when a is positive, our graph is defined from the first quadrant and the third quadrant. And also, we noticed something here. We noticed that when we are approaching 0, because we're going to have y is equal to 1 over 0, we can never divide any number by 0. That is undefined. So we notice that we never get to touch y equal to 0. So this means that there's something about y equal to 0, right? And we also notice that from this side, we also never touch the line x is equal to 0. So we also have something else, the line x is equal to 0. So what do you know about the line that we always approach but never touch? So you can see that this yellow graph here is always approaching 0. It's getting close to 0 but never touches 0. So because if you continue here, we're going to always have something like that, but it will never touch 0. So we have those two things. We have two lines here, and those lines, that's what we call them asymptotes. So that's what you have to know about asymptotes. It's a line that a graph gets close to but never touches. And if it does touch that line, the graph will be undefined. So that's what you need to know about asymptotes. We also said we're going to learn about the axes of symmetry. Like the word said, axes of symmetry. So we look at where the graph is symmetrical. That is, we get the mirror image of a graph. So from here, we're going to find what is the axis of symmetry. So you can see here that this graph is in twos. It's in two pieces, that's what I mean. And you can see that it is symmetrical about that line. You have this half which is similar to that half. So this is your line of symmetry. And you can also see that this is the second line of symmetry, because you have this top part here which is symmetrical about that part. Same thing here. If you fold this, you're going to get similar graphs. So that's what we mean about axis of symmetry. Now you're going to note that from a parabola, we only had one axis of symmetry about the turning point, right? But now we have two axes of symmetry. We have this line here, and we also have this second line here. So you can see that this line touches here at x is equal to 0 and y is equal to 0. What do we know about the equation of a line that touches at x is equal to 0 and y equal to 0? We know that it is y equal to x, right? The gradient is 1 if the graph touches 0 and 0. But now you can see that, okay, this one has a positive slope, this one here. So this is going to be y equal to x. And this one is also passing through the same point. So it's going to be y equal to minus x, because we can see that the slope is negative. So now you already know another thing, that you have two axes of symmetry, which is y equal to minus x and y equal to positive x, because these two touches there. And then we get to the point, once the graph shifts, also the axis of symmetry will shift. That's what you should know. Do not always assume that the axis of symmetry are equal to y equal to x and y equal to minus x. We move on. We also spoke about the range. So what is the range? We know that the range is where the graph is defined by the y-axis. So you can see that the yellow graph here, it's defined throughout all the numbers, but it cannot be, y cannot be equal to 0. You see, you can see that your graph is defined everywhere, but not at the asymptotes. So you can tell here, y is an element of real numbers, but y should not be equal to 0, right? Similar to the domain from the y-axis, you can see you have your graph throughout the y-axis, but you do not have it when x is equal to 0. Then that means we have two things. We have x is an element of real numbers, but x cannot be equal to 0. That's how it should be. That's how it is here. When you have a basic parabola, you have not shifted anything. Your domain, x is the element of real numbers, and x should not be equal to 0. This will not change unless your graph is shifting. But all you need to know that your graph is not defined at your asymptotes. So now that we understand this basic, we're going to talk about what happens when a is negative. So now we have y equal to minus 1 over x, and we can see that a is negative 1. We still do this with similar approach. We equate the values of x and then we find y. I want you to note something from the negative x values. From the negative x values, so from the previous equation when a was equal to 1, these values were negative, and hence we had this graph on the third quadrant. And you can see now that when x is negative, the values of y are positive. That means this graph has shifted to the positive side. What does that mean? It means it has reflected by the x-axis. So all you need to know, without drawing point by point, you can use the similar graph but shift it by the x-axis. And you do the similar thing here. You can see that when x was positive on the previous equation, we had the graph on the first quadrant. So now we do the similar thing here. We're going to reflect it. As you can see that when x is now positive, the y value is negative. So this quadrant is shifting to the fourth quadrant. So we're not going to draw point by point. We're going to do a reflection by the x-axis, because that's what is going on from the points. So you can see that when a is negative, the graph is defined on the second and fourth quadrant. So that's what A tells you. It tells you where your graph is defined and your shape. So note that even though A is negative, you still have the same axis of symmetry, right? You still have the same axis of symmetry, and you still have the same asymptotes. And you still have the same range. The only thing that A changes is where your graph is defined, and not your axis of symmetry, and not your asymptote, and not your range and domain. So I want to show you what happens when the value of A is getting bigger. Because we talked about what happens when A is greater than 0 and what happens when A is less than 0. Now I want to show you what happens when A is getting bigger on the positive side and what happens when A is getting bigger on the negative side. Note that we're not talking about A is equal to 0, because when A is equal to 0, this whole thing becomes 0, and therefore we do not have a hyperbola. So for a hyperbola to be defined, A cannot be equal to 0. So let's see what happens when the value of A is getting bigger. So we're going to use GeoGebra to see that. So this is a value of A, and you can see I'm going to change this. We have the same equation, y equal to 1 over x, and we're going to change the value of A. So A is positive, hence it is defined on the first and the third quadrant. And then when it becomes bigger, you can see what is happening to the graph. It's getting steeper. So it's moving away from 0. And when A is getting smaller, closer to 0. And you can see even from here, we have our asymptotes, the blue line, which is your vertical asymptote, and your horizontal asymptote. And now I want to show you what happens when it's getting bigger on the negative side. So this is A equal to 0. As you can see, we do not have a hyperbola there. It is not defined. Hence, A cannot be equal to 0. And when A is becoming more negative, you see? Okay, let's start with when A is negative. What I was talking about, it's defined on the second and the third quadrant. And when it becomes bigger, it does a similar thing. It's getting steeper. So the value of A tells you the shape of the graph and the steepness of the graph, like the gradient of your graph. Thank you for watching. Please do comment down below on what you would want to see on other videos. I would really appreciate that, and I will see you on the next video.